Good morning, students. We have been discussing with the chapter electricity. Have you gone through it? In the last class, we discussed about the factors affecting the resistances, isn't it? So, what are the factors affecting resistance? First one is length of the material. Second is area of cross section, and third is nature of the material. You know that. How is length and resistance related? Resistance is directly proportional to length, and resistance is inversely proportional to area, and finally it depends upon the nature of material. When we change the material also, resistance is affected. Okay, then we created one equation. What was the equation? R equal to rho into L by A, where L and A are the length and area of cross section of the material, and we introduced a constant called resistivity. What is the name of resistivity? Another name of resistivity? Anyone? As specific resistance. And resistivity is defined as the resistance of the material having unit length and unit area of cross section. Okay. Then unit of resistivity, very important. What is the SI unit of resistivity? What will you say? It is ohm meter. Ohm meter. Okay. Now resistivity is a characteristic constant. That means it doesn't depend upon length and area. That is, when length is increased or when area is increased, there is no effect on resistivity. Only resistance changes. And resistivity is a characteristic constant. But it depends upon the nature of the material and temperature. Clear? Now, today we are going to study another important topic, again related to resistors, resistance. What is that? It is the combination of resistors. That means you have to study, in your higher classes you have to study large number of electrical circuits. Okay. Now we are studying simple circuits having one or two resistances, then cell, battery, switch, like that. Small circuits you are studying. Okay. In larger circuits, there will be large number of, for example, if you are taking an electrical appliance, it will consist of large number of resistors. There will be need of large number of resistors in that particular appliance. So, the resistors can be connected in two ways. Okay, resistors can be connected in two ways in an electrical circuit. So today we are going to study how we can connect the resistors. What are the two ways by which we are connecting resistors in an electrical circuit? Okay, so the topic is, what is that? Combination of resistors, or a system of resistors, which are with the connection of resistors in an electrical circuit. Any way you can say. Okay, so let me introduce the topic. It is combination of resistors. So, the main two ways with which we can connect the resistors are, first one is resistances in series. Okay, resistance is in series. And second is resistance in parallel. Resistance in series and resistance in parallel. Each one we have to study in detail. Numericals are there based on this concept. Okay, so be careful, listen carefully. It is very easy also if you are listening. Otherwise, it will be difficult for you to solve the numericals also. Okay. So, first one, in series. What do you mean by series connection? Series connection means you already studied the symbol for resistance. We are not showing the resistor here. We are not drawing the exact picture of resistor. We are using the circuit symbol for resistance. What is the circuit symbol? This is the circuit symbol for resistance. You remember, right? Now, if there are a large number of resistors we have to connect in an electrical circuit, we can connect it either by series or by parallel, depending upon the need. Understand? So first, if you are connecting in series means, for example, if you have a resistor A I am naming it. Okay. Resistor A. This is A. And another resistor in B. And third one is C. I have to connect it in series. Means the end of this resistor, it has two ends, right? The end of this resistor is connected to the end of B. Understand? Again, the end of the resistor C is connected to the end of resistor B. That means end to end connection. What is that? End to end connection. This type of connection is called series connection. Okay. So if there are large number of resistors, you can connect it like this. That is, the end of one resistor is connected to the end of the other resistor. In such a way, we can form a series combination. Understand? Now, in second case, parallel. Parallel means again if you have three resistors with you. Three resistors are given A, B and C. Now, if I am connecting like this way, look here, all the ends, this ends is connected to a single point. Okay. Again, the other ends, all the other ends are connected to another common point. So, if in such a way, if I am arranging the resistors, such a combination is known as parallel connection or parallel combination. You got it? So, series combination means end to end connection. Here, the ends are connected to a common point. Two ends are there, so two ends will be connected to corresponding two common points. So, how many resistors are there? All the ends will be connected to a single point in this side as well as on the other side. Understand? Such a way of connection is called parallel connection. Clear? So, in each connection, we have to study in detail how the current flows, how the potential difference varies, how will you find the total resistance if there are n number of resistors are present there. So many things are there. Okay, so shall we move to that? This is clear? Okay. So first we will discuss the series connection. So I am considering a circuit having three resistors. Let the name of resistors be R1, R2 and R3. Okay. So this R1, R2 and R3 are the three resistances. We have to connect it in which connection? Parallel connection. So I am connecting like this. In series connection. This is R1, this is R2 and this is R3. Okay. Now this is connected to a cell or a battery. Okay, cell or a battery. I am taking a battery here. Then switch is there. Now I placed one ammeter also. So this is the connection for ammeter. Now the direction of current. Everything is important. Direction of current. To measure the potential difference, I placed what? What is the instrument to measure potential difference? S, voltmeter. How will you connect voltmeter in a circuit? In parallel. So I am placing a voltmeter here, which is placed in parallel. Clear? Now again, positive of the voltmeter should be connected to negative of the ammeter. Like that you have to arrange. Clear now? This much is clear. So this is the connection in which the resistances are connected in series. Now listen. You have studied Ohm's law, that you have to remember right now. What is the equation? V equal to IR. V equal to IR. So let it be here. We need this equation in between. So I just wrote the equation here, V equal to I into R. Understand? Now in series connection, there are certain properties. Listen carefully, okay? If you are studying this now, you can do it by yourself. It is very easy. So please listen to the points that I am saying in each connections. First I am saying about series connection. Now listen, here we are applying a battery. A source of voltage is provided here with the voltage V. Let the voltage be V. Understand? Now when I switch on this particular key, what will happen? The current starts to flow. The current I starts to flow. Clear? But in the case of a series connection, if I am measuring this particular, the current across this R1, then current across R2 and current across R3, the current will be same. That is the first point. So in series connection, how? In series connection, the current will be same. For example, if 6 ampere current is flowing, means if I am measuring across this R1, if I am measuring the current, it will be 6. Again R2 it is 6, R3 it is 6. Okay, so it is clear that how many resistances we are connecting in series, no issue, because the current through every resistor will be the same. Okay, so I can take through R1, R2 and R3, the current will be same. So what is the current? I is the current. Clear? Clear? Okay. Now listen, what about the potential difference? When I measure the potential difference across R1, it is, for example, if I am giving a potential of 5 volt, if I am providing a potential difference of 5 volt through this cell, because cell is the device which is used to maintain the potential difference, or battery is a device which is used to maintain the potential difference, isn't it? So by connecting a cell, it will provide the necessary potential difference needed to drive this circuit. So if I am giving a 5 volt battery, the potential will be divided across the 3 resistors. That means I can measure with the help of a voltmeter. When I measure across R1, I got it as, for this is just an example only, let it be 2 volt. Okay. Again for R2 I got 1 volt. Understand? Again R3 I got 2 volt. Okay. 2 plus 1 plus 2, which will give you 5. So how much voltage here we are providing? This will, what will happen? This will get divided for each resistors. That is the second property. So first is current remain the same, but the potential difference or the voltage will be different. So for R1 I will write V1, okay. R2 I will write V2, R3 I will write V3. Why I wrote V1, V2, V3? If it was same, I will write V out. Understand? But since it is different, it is getting splitted. That means this V is getting split into 3. Which are they? V1, V2 and V3. You just assume like that. Okay. If it is 5 means it is getting divided as 2 plus 1 plus 2. Isn't it? So to differentiate between each, I gave the name V1, V2 and V3. Clear? So across this R1, I have a potential of V1. Now across this R2, I have a potential of V2. And for R3, I have a potential of V3. Okay. So now we will move to the derivation part. This much is clear now. Once again I am saying this is series connection. In series connection, the large number of resistors can be connected like end-to-end connection. That is, the end of one resistor is connected to end of the other resistor. And in series connection, the current flowing through the circuit will remain the same for each resistor, whereas the potential difference will be different. It can be measured with the help of a meter as well as a voltmeter. Understand? So to find the effective voltage, what will you do? We will add the voltage of each resistances, isn't it? We will add the voltage of each resistances. So we are moving to that step now. What we are going to do? We are going to add add individual voltages to find the total voltage. Okay? So you can write this equation as, listen, I am going to add V is equal to V1 plus V2 plus V3. Why I write this? Because the voltages are different for series resistances. Clear? Now listen, what is V? V is I into R according to Ohm's law. So I will write here, IR, this is general expression for V, isn't it? Now for V1, you know that the current is same. So if I amount of current is flowing means it will be same in the case of R1, R2 and R3. So for R1 I can write I into R1. I into R1 which will give you V1. Again for R2 you will get I R2 and R3 you will get I R3. So if I am writing the expression here, it will be I R1 plus I R2 plus I R3. Clear? So now listen, what is common here? I is common. So I can write this expression as I R1 plus R2 plus R3. Isn't it? So I will get cancelled. What is the final expression? R equals R1 plus R2 plus R3. So what do you mean by this equation? Listen here. The total resistance of this combination, because we are using large number of resistances and the resistance are connected in series. So to find the effective resistance or to find the total value of resistance, we should add the individual resistances. Understand? So R equal to R1 plus R2 plus R3. So if you are giving there will be lot of numericals in this section. If you are having 4 ohm, then 2.5 ohm and 1 ohm. You can easily find if it is in series combination. What will you do? You will just add the 3 resistances like 4 plus 2.5 plus 1, which will give you 7.5 ohm. Understand? So this is the way to find the effective resistance when the resistance are connected in series. Okay? So now we are moving to the second combination of resistors, which is parallel combination of resistors. Okay. So our second combination is parallel combination. Parallel combination. I already told how to connect the resistors in parallel. You know that. So I am taking 3 resistances here. My resistance are R1, R2 and R3. So let the resistance be R1, R2 and R3. Clear? Now I am connecting this particular system to a battery. Actually it is very easy. Okay. If you are getting it, you can do it right now. No problem. The key is there. Now ammeter is there. Ammeter is always connected in series. Remember that. Okay. And a voltmeter also connected here in order to measure the voltage, and the voltmeter is always connected in parallel. Clear? Now the direction of current. Okay, so our circuit is ready. Now the points here are to be noted here are just the opposite of series connection. So you can easily say it now. Can you? First point in series was the current remained the same. So what will be the result here? Yes, the current will be different. That is, if I amount of current is flowing, when it reaches this junction, no, it will get split into 3. Since there are 3 resistors, That means it will change to I1. Here it is I2 and here it is I3. Understand? So, in parallel connection, first point is in parallel connection, which quantity will remain the same? Yes, voltage will remain the same, but the current will be different. So, again we got the second point. So, the first point is the current will, first point is current will be different. Whereas, second is voltage will be same. Clear? Current will be different and voltage will be same. Okay. Now, we will move to the derivation part. That is to find the total value of resistance in a circuit containing resistors in parallel. Okay. So, for the first series connection, we got the expression as R is equal to R1 plus R2 plus R3. Very important. Okay. Usually in board questions, this equation is asked to derive with the help of a diagram. So, you have to study it properly. Now, we are moving to find the total value of resistance in parallel combination. So, look here. Here, which one is different? I is different. So, it gets split into I1, I2 and I3. So, to find the total amount of current, I have to write this equation. What is that? I is equal to I1 plus I2 plus I3. I equal to I1 plus I2 plus I3. Okay. Now, as by Ohm's law, you have studied again V is equal to what? IR. V equal to IR. Okay. So, instead of I, what can I write? Instead of I, V by R. Isn't it? From this equation, instead of I can use V by R. Now, look here. Substitute the value for I. Substituting the value for I, you will get, what is the expression? I for I, you can write V by R. V by R. Which is, again here, you know that which quantity is same here? Potential or the voltage is same. That means for R1, R2 and R3, what is the voltage? V is the voltage. Understand? V is the voltage. So, across R1, R2 and R3, it will be same. It is V. Clear? So, I can write V for I1. V for I1, but the resistance is R1. Okay. V for I1, but the resistance is R1. So, for I1, what is the equation? V by R1. Understand? Plus V by R2 plus V by R3. Clear? Look here, which quantity is constant? V is constant, isn't it? So, you can write the expression as 1 by R. We get cancelled, okay? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That's all. So, this is the equation to find the effective resistance for a parallel combination. Look here. 1 by R. That means reciprocal of R. Okay. Reciprocal of the effective resistance is the sum of what? Reciprocals of individual resistances. The reciprocal of the effective resistance is the sum of the reciprocals of the individual resistances. Understand? So, this is the expression to find the total resistance in a circuit in which the resistors are connected in parallel. Clear? So, if you are getting two resistors, for example, if you are having 2 ohm and 4 ohm, how will you find? 1 by 2 plus 1 by 4. So, what is the answer? 4 plus 2 by 8, which is 6 by 8. But here, 1 by R you will get as 6 by 8. Understand? So, here always students make a mistake that they will not find the reciprocal again. Only by taking the reciprocal, you are getting the actual value of R, isn't it? So, R is equal to 8 by 6. R equal to 8 by 6. That is 4 by 3. Oh. Clear? So this is how we are finding the effective resistance for a parallel combination. Understand? Again, we are connecting three resistors R1, R2 and R3 in parallel. Parallel means the end of each resistor is connected to a common point here as well as a common point here. Okay. Now, a voltmeter is connected in parallel to measure the voltage. Then it is connected to a battery, key and a meter. Clear? Ammeter is used to measure the current. Then first we switch on, then current starts to flow, but in a parallel connection. When it reaches here, the current will get split. For example, if I am sending a current of 4 ampere, 4 ampere will get split to these three. Like 1 ampere, then 2 ampere and 2 ampere. Sorry, 1 ampere. Okay. So 1, 2 plus 1 will give you 4. So how much current is going here? It will get split into the resistors, the number of resistors. And then depending upon the value of resistors, the current will differ. Understand? So then to find the total value of current, I have to take this equation, I equal to I1 plus I2 plus I3. Now by Ohm's law, what is the expression? V is equal to I into R. And from this expression, I equal to V by R. Okay. So I wrote V by R. This is general expression only. Now for I1, I2 and I3, you know that current, even though current is different, voltage is same. That means if I measure the voltage across R1, voltage across R2 and voltage across R3, I will get the same value. That means if I am sending a 3 volt battery, this R1, R2 and R3 will be having 3 volt each. Understand? So we will substitute the value like V as constant because the potential is constant. We get cancelled and 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the reciprocal of effective resistance, isn't it? Reciprocal of effective resistance, and it is equal to what? The sum of the reciprocals of individual resistances. Sum of the reciprocals of individual resistances. Okay. Now we will just have a distinction between these two. That means already we said, but we can draw a table and we can note the points so that it will be easy for you. Okay. So first is series connection and second is parallel connection. You can note the points, okay? So what is the first point? First point is end to end connection. First point is end to end connection. Now here, what is the first point? The terminals of our 2 points are connected to a common terminal. All the leads, we can say it as leads also, all are same, okay? The ends are connected to where? A common point. Clear? Now, which quantity is same in series? Current is same. So electric current is same. Here, which quantity is same? Potential difference or voltage is same. Okay, potential difference or voltage remain the same. Clear? Now the third point is, now you are able to say, right? Yes, electric current is same, but which quantity is different? Potential difference is different. Potential difference or voltage is different. Okay, here, electric current is different. Clear, no? Now look here. How will you find the effective resistance? Yes, the effective means total resistance. Effective or the total resistance is the sum of the resistances of, I am writing in short, okay, resistance of individual resistances. Sum of the resistance of individual resistance. And in this case, the reciprocal of effective resistance is the sum of, don't forget to write the word reciprocal, okay, reciprocals of individual resistances. Reciprocal of effective resistance is the sum of reciprocals of individual resistance. Now here, one more point I can add, that is, if I take two resistance like 2 and 4, okay, in the case of series combination, we know that to find the effective resistance, we will take the sum, isn't it? So I will take 2 plus 4 so that I will get an answer like 6. Now if I am taking 2 plus 2, it will be 4, isn't it? 3.5 plus 1.5, you will get it as what? 5. Understand? That means nothing here, just listen. Here I have taken two resistances. In this first case, 3.5 and 1.5. 3.5 is larger than 1.5. But the effective resistance is larger than the largest resistance. Understand? Again 2 plus 4. 4 is the larger resistance out of these two. But we are getting a value which is again higher than the largest resistance. So I can say in general, the effective resistance in series combination, I will write like RS. Okay, that means effective resistance in series combination. Effective resistance in series combination is always greater than, what will you say? The greater than the greatest of what? Individual resistances. That means if you are having 2, 3, 4, etc., you will take the sum. Out of 2, 3, 4, which one is larger? 4 is larger. But when you are taking the sum, you will get 2 plus 3 plus 4, which is 9, isn't it? This 9 is greater than 4, isn't it? That's all. So 2 plus 3 plus 4 will give you 9. And this 9 is the effective resistance. This effective resistance is always greater than the greatest of the individual resistance. Now you got it? Okay. Now moving to parallel connection. Again listen here. In parallel connection, what is the expression? 1 by R is equal to 1 by R1 plus 1 by R2 plus etc. If a large number of resistors are there, we will take like this. Okay, we will take the sum of the reciprocals of resistances. Now, if I have resistance like 2 and 4, I will take 1 by R is equal to 1 by 2 plus 1 by 4. Isn't it? Now listen, you can cross multiply, so you will get 4 plus 2 and 4 into 2 is 8, that is 6 by 8. I already told that this 6 by 8 is 1 by R. I have to find R. Keep it in mind always. So R is equal to 8 by 6, which is 4 by 3. It's 1.33. Isn't it? Now listen, I took the resistance 2 and 4. But you are getting a value which is less than the smallest resistance of the individual resistances, isn't it? That is, always in the case of parallel combination, the effective resistance will be smaller than the smallest of the individual resistances. Okay, so we can write that point also. In the case of parallel combination, just the reverse of series. In the case of parallel combination, the effective resistance, that is RP, effective resistance in parallel. Okay, so RP is always less than the smallest value of the individual resistances. Clear? So once again, in series connection, it is end-to-end connection. In parallel connection, the ends are connected to a common point. And electric current is same, but potential is different in the case of series connection. Whereas in parallel, the potential difference will remain the same, but the electric current will vary. Next is the total resistance we can find in series connection as the sum of the resistance of individual resistances, whereas in the case of parallel connection, the reciprocal of the effective resistance, that is 1 by R, is equal to what? The sum of the reciprocals of each value of the resistance. Okay. Now, when we find the effective resistance, it is always greater than the greatest value of the individual resistance. But in the case of parallel connection, the effective resistance will be smaller than the smallest value of the individual resistance. So, these are the points to differentiate between series and parallel connection. Now, we are moving to the the advantages of parallel circuits. Okay, is there any advantage for parallel combination over series circuit? It's a very important question usually asking for board exams. So, we will look into it. Okay. Okay, now we are going to discuss one of the important topics related to this combination of resistors, that is advantages of parallel combination over series combination. Advantages of parallel combination over series combination, or it can be asked like disadvantages of series circuit over parallel circuit. In such a way also it is used. Then another question, all our answers are same. Okay. Now another question is why we are using parallel connection household circuits. That is very important. That is, in our houses we are using, for wiring and all, we are using parallel combination. Okay. Why we cannot use series combination? That is what we are going to discuss now. Okay. Now look here. First point is, in series combination, if one electrical appliance stops working, all the appliances stop. You know, large number of appliances we are using, refrigerator, washing machine, TV, so many other, fan, light, etc., etc. So, in the case of series connection, if we are connecting in series, wiring and all, if it is done in series means, what will happen? When one doesn't work, the others also doesn't work. That means for all the appliances, it is having a common switch. That is the second point. There is only one switch. Switched on and switched off together. Is that possible in a house? No. So, in the case of parallel connection, if one stop also, due to some defect, if one is not working, the others will work because connections are different. Clear? Now, each appliance has its own switch. That is the advantage of parallel combination. Each appliance has its own switch. Next, third is, do not get the same voltage. You know that from the electric post, you have seen that some wires are connected to our main switchboard and all, no? And there we are actually from electricity board, we are getting almost 220 volt power supply. Okay, 220 volt power supply in India. Now this 220 volt, when it is entering into the main switch, it should be given to all appliances equally. And if you want to get the voltage same, means which connection we have to use, as it is parallel connection. If we are using series connection, this voltage will get distributed and go, no? So some appliances will not work if it is not getting proper voltage. You know that some appliances need what? Because voltage fluctuations, sometimes voltage fluctuations will happen and the system get damaged, isn't it? So voltage should be proper. To get proper voltage, that means equal amount of voltage should be given to all appliances. So for such purpose, which connection is more advantageous? It is parallel connection. Now the fourth point is, you know that in the case of series combination, if the total value of resistance is added, overall resistance is added, the resistance value will be more high, more large, So this larger value of resistance will decrease the amount of current flow. You know that. Because R is inversely proportional to I as per Ohm's law. So when the resistance increases, the current flow will be less. So in some appliances, proper amount of current is not flowing and it is not working, isn't it? In such some things like such issues will happen if it is connected in series. Understand? Then in parallel connection, that is the resistance, overall resistance will be decreased, isn't it? So in parallel connection, the overall resistance will decrease so that high amount of current can flow. Huge amount of current can flow, and it can be worked for special purpose and all, isn't it? So these are the advantages of parallel connection. Especially if one appliance stop, the others will work. That is the advantage of parallel over series. Then each appliance can have individual switches. Each appliance can have its own switch, so that if I want to switch on the fan of one room and switch off the light, means I can do it. But in series connection, if I switch off the fan, the light goes. Understand? Everything will go. Okay, that means everything is controlled by a single switch in the case of a series combination. And in parallel combination, you will get the same amount of voltage, which is 220 volt, to all the appliances. Equally it is giving, and then the current from the power supply is high. Why? Because the resistance is very low. The overall resistance is very low in the case of a parallel combination. Understand? So these are the points regarding the advantages of parallel combination. Now we have to discuss a few numericals related to this section, that is series and parallel combination, that we will discuss in the next class. Understand? I hope you understood the concept. I am again saying it is very important. The combination of resistors, series and parallel connection, how you are getting. There will be questions like derive an expression for the effective value of resistance in series combination. That means effective value what? R, the total value of resistance, R is equal to R1 plus R2 plus R3. That equation you have to derive. For that you have to draw that circuit diagram connected to a cell and all. Then you have to explain each and every one. Consider three resistance R1, R2 and R3 which is connected in series. Then V voltage is providing, I current is flowing. But in series combination, the voltage will get splitted and the current will be same. Now to find the total voltage, I will take like this and this, so and so. So this type of derivation part you have to write. It is very important and asked for 5 mark questions also. Clear? So like that, parallel combination also you have to study. Write it and study so that you will be able to give it, okay, during the exams. And go through it. Clearly you have to go through it. If you have any doubt, contact me. I will clear your doubt. And in the next class we will discuss the numericals. Okay. Have a nice day and thank you.